Hello learners, welcome to Manifested online classes. My name is James Kenyani. We are going to proceed with our topic on further logarithms, and in today's lesson we are going to look at further solutions to logarithmic equations. So the lesson will be further solutions to logarithmic equation. The main objective of this lesson is to give the learner varied skills on solving logarithmic equations. And as they said, practice would make perfect. We are going to do that by looking at several examples, and I will go through them to help you understand some of the concepts you've learned in the previous lessons. So I'll start with the first question. For example, so learner, that is the first question we have, but it is very interesting. One is asking, where is this zero coming from? So you might do something to that zero before we continue. I said if the base is not given, if the base is not given, assume it to be 10. Assume it to be 10. So I want to deal with that zero. Initially we saw 10 raised to 0 is 1. 10 raised to 0 is 1, meaning that the logarithm of 1 to the base 10 is equal to 0, is equal to 0. So when we write that, this one will likely replace that 0. So when I come and rewrite it, it will be 2 log x. So I'll assume now we have 10. Base 10, subtract log base 10, 2x plus 3. I'll replace this with that 0. I'll replace what I've got here at that 0. So I'll have log base 10, 1. You see, I've already replaced that 0 because all of them are to the same base. This is the same as having the other law of logarithms. You say, but 2 log base 10 x is equals to log base 10 x squared. So you'll substitute where we have that. So you'll have log base 10 x squared learner is equal to log base 10 2x plus 3 is equal to log base 10, 1. So laws of logarithms, where we have a minus, it is the same as division. It is the same as division. So this is the same as having log base 10 x squared over 2x plus 3 is equals to log base 10, 1. So actually base 10 is common, it can cancel. So you'll have x squared over 2x plus 3 is equal to 1. So we continue, learner, cross multiply. X squared is equal to 2x plus 3. I can bring it to the right hand side to make it a quadratic equation. So x squared minus 2x, x squared minus 2x, I've taken it to the left hand side, minus 3 is equal to 0. I have a quadratic equation, so I'll use the product sum. 1 times 3, the product is equals to minus 3. The numbers, the sum is equal to minus 2. So I should get two numbers. When I multiply them, I get minus 3. But when I add, I get minus 3. So the numbers are minus 3 and 1. They'll help me to solve that equation. I'll break up that using this, the sum, the numbers. So I'll say x squared minus 3x plus 1 minus 3 is equals to 0, learner. So you'll come here and factorize x into x minus 3 plus 1 into x minus 3 gives us 0. So x plus 1, x minus 3 is equals to 0. X is either -1 or 3. Those are the values of x in that quadratic equation. So check. We move to another example. Example Q. Example Q, learner, where we have log base 3 4 plus log base 3 x is equal to minus log base 3 5 is equal to log base 3 2. So our main effort is to find the value of x. So they can say in that example, find x. That is a logarithmic equation. We call that one a logarithmic equation, learner. So I hope you've got what happened here. You only work when all the terms given are of the same base. Like all these terms are of the base 3, are of the base 3. So I can come and write, since they are of the base, laws of logarithms. I'll have log base 3. I'll have, this is plus, so it will be 4 times x. 4x divided by 5, laws of logarithms, is equal to log base 3 2. So what happens there? Log base 3 is common. I can do away with it. So what will I remain with? 4x over 5 is equal to 2, learner. I'll multiply both sides by the reciprocal of 4 over 5. 4 over 5. So I'll have 4 over 5 x times 5 over 4 is equal to 2 times 5 over 4. So 5 cancels with 5, 4 cancels with 4. I remain with x is equal to 10 over 4, which will give us 2.5. That is the value of x. That is the value of x. So if you have the same base, you just continue. Let's look at another example. Let's look at another example. This is PQ. Let's look at R. Let's look at the last example, R. Example R. So Lana, that is a very interesting one. It is a simultaneous equation. Solve for x in these simultaneous equations. So in the first equation, x plus y is equal to x times y is equals to 80. So you can say using one, if x, y is equal to 80, it means that y is equal to 80 divided by x. 80 divided by x. You'll then substituting y in equation 2. So now we substitute y in equation 2. What will we get? It will now become into log x. Log x, subtract 2 log. I'll now put where y is, I'll put 80 over x. 80 over x is equal to 1. Is equal to 1 lana. I said where the base is not given, where the base is not given, we assume it is 10. So if that is the case, this one here, when we come with that one here, we know 10 raised to 0 is equal to 1. 10 raised to 0 is equals to 1. So you can say log of 1, log of 1, log of 1, log of 1. 10 raised, we can use 10 raised to 1 is equal to 10. Is equal to 10. It is the one that will give us. So it will mean the log of 10, the log of 10 to the base 10 is equal to 1. So where 1 is, we shall substitute. You actually substitute where 1 is. So where 1 is, we write that. So you'll say 1 is equal to log base 10, log of 10 to the base 10. So that's what you'll write there. So you'll come and say log x, log to the base 10x, subtract 2 log to the base 10, 80 over x is equal to log to the base 10, 10. We'll reach somewhere where the logs will go, but let's continue. Log to the base 10x minus the other laws of indices. You'll have log to the base 10, 80 over x squared is equal to log to the base 10, log to the base 10, 10. So we'll continue. We'll continue with our equation. Let's continue with that equation. We come here, laws of indices. You'll have log to the base 10 x over 80 over x squared is equal to log to the base 10, 10. So the log to the base 10 is common. That is common. So you'll have x divided by 80 over x squared is equal to 10. Is equal to 10. This will become x times x squared over 80 is equal to 10. Is equal to 10. So you'll come and have x times x is x cubed. You'll have x cubed over 80 is equal to 10. Is equal to 10. Is equal to 10. So x cubed will be equal to 800. So x will be equal to the cube root of 800. So with our calculators, we'll get the cube root of 800. Cube root of 800. So there is an easier way we can, if you want to get the cube root of 8, you can still cube root of 8. This is the same as having the cube root, the same as the cube root of 8 times the cube root of 100. The cube root of 100. The cube root of 8 is 2. The cube root of 8 is 2 times, we shall then work out the cube root of 100. So this will work to 2 times the cube root of 100. So it will be 2 times 4.321, and this will give you 8.641 1, 8.4642. So that is how we work out that. So without wasting a lot of time, I'll give you as an assignment related to the same. So before we go to the assignment, there is something we need to check here. This was supposed to be the computation from our calculators was supposed to be 4.641. 4.641. 4.641. So if you work out that, it gives us that's 2, that's 8, that's 2, that's 9. So that is the correct answer. So I'll go straight to the assignment. So Lama, those are the questions. In A, log x is equals to 4 log 2. B, log 12 plus 3 log x is log 96. C, log into brackets 3x plus 4 subtract log into brackets 3x minus 1 is equal to 1. D, 1 plus 2 log base 10 x, log of x base 10 subtract log of x squared minus 7x plus 2 to the base 10 is 0. Find x. E, log of 2 to the base x plus log of 8 to the base x is 4. So I said in some cases where the base is not given, you assume it is 10. And you deal with this first. You write it in a logarithmic form to the base 10 before you simplify. So thank you very much for that, audience, and I hope to meet you in the next lesson. Bye-bye.